Hello, and welcome to this third episode of Getting Started with Java and AI. In this episode, we're going to look into how we can preserve state between different calls that we're making to an AI model. Because by default, when we call LLMs, we send a message, it responds with a message, we send another message, it has no idea of the previous context, the previous conversation. So we have to find a way to keep memory between those different calls. So with Quarkus and LangChain4j, it's actually really easy to do. Spoiler alert, it comes out of the box. But let's look into it a little bit more because there's a little bit more to it than that. So stay tuned, let's dive right in. So if you watched one of the previous episodes, you might remember that we were calling an LLM to get it to generate a poem for us. And in this case, we wanted to write a poem about Quarkus AI. So here was the REST endpoint where we were calling a my AI service, write a poem method with the parameters Quarkus AI, and we wanted it to return 4 lines. And then in the AI service, what we did was we created an interface with a whatever name. We register AI service as the annotation. That's what wires it up in Quarkus and LangChain4j. And then provided a system message and a user message to provide some context about the call that we were going to make, and we asked it to write a poem about the topic, right, that we pass in as a parameter, and then it should be X amount of lines long. Now, that worked great, but it's just one question that we're asking. What if we had asked it a follow-up question? Would it remember that we were still in this context of you are a professional poet, or would it forget that? So by default, LLMs are stateless and it would not remember that. In Quarkus and LangChain4j, by default, memory is enabled, but let's check it out and see what actually the difference is. So I created another project here, memory, and you can access that in my GitHub. And you can see that I created this entry command file, and we have a couple of classes here. I basically wanted to create a CLI interaction this time, so no REST endpoint. We can access this through the CLI. And we have 2 different commands here. We have an hello command and we have a choose your language command. We'll visit the choose your language command in just a minute. But first we want to call this functionality. So the command is hello. And so basically when we call our Java file and we pass in the parameter hello, it's going to activate this run method. And in this run method, there is a first call to an AI service where we ask it, what is Java? It'll respond with, Java is a very robust language and enterprise ready and has a great ecosystem and blah, blah, blah. All these great things about Java, right? And then we call the model again and we ask it, can you give me a hello world example for it? Now, this it is very ambiguous, right? If the LLM doesn't know that we were already asking it about Java, it might produce an hello world in another language. And I can only guess that it would be Python because LLMs are typically trained with Python, so they're a little bit biased. But because the first question, what is Java, we can assume that it might remember, if we have memory, that it will return a hello world with Java. So let's try that out. So first, of course, we need to configure our AI service here, right? So we have an my AI service in this case. And as you can see, we still have the same register AI service. We have the interface, my AI service. And I created 2 methods here. So I created a chat method where you just pass in the message. And then I also created a parallel chat, and we'll visit that in just a minute. But as you can see here, I have 2 commented pieces of code here. And so they have the same parameter, chat memory provider supplier. And that is how you can configure with Quarkus and LangChain4j how to keep state, how to keep a memory of a conversation with an LLM. So you can see there are 2 examples here. There's one, no chat memory provider supplier, which, as you can imagine, would mean don't keep memory, just every call is independent and there's no kind of follow-up. Don't make the LLM remember. In fact, we don't actually ask the LLM to remember. What's going to happen instead is that if we enable memory, we're going to have the history of the conversation as context for our subsequent calls. So we're going to see that in our logs in just a little bit. The second one here, you can see register AI service, bean chat memory provider supplier. That is actually the default in Quarkus. And so I have it commented out. It wouldn't matter if I uncomment it or not. It's the default in Quarkus. So we can just leave it commented out, and we're going to see that our memory is by default going to be preserved. So let's try it out. Let's call our application here. Let's do it in Quarkus dev mode, and we'll pass in, remember, our entry command file here. We have the method for the hello command with name hello. So we need to pass in that parameter hello, and let's see what happens. So now we're starting our Quarkus project, and we should see a few interactions, right? Because we asked it to do two different things, system.println, what is Java, and then can you give me an example? So here we are logging it. So you can see here's our first request where the content is what is Java. And then we see a response from the LLM that says Java is a high-level object-oriented programming language, and some more information about how awesome Java is. And here is our second request. So we can see here that we have an additional kind of section here. So we see here in the body, messages, content, what is Java? So our previous question is included in this interaction. And then we also have the response from the LLM, the previous response that we pass back into the LLM. And then we ask it, can you give me a hello world example for it? So all that context from the previous call is preserved. And then we can see that it responds, certainly a hello world program in Java is quite simple. And so it'll respond with a hello world example in Java because we preserved our memory and it knows from the context that we were talking about Java. So this is by default the default functionality in Quarkus with LangChain for J. So I didn't actually have to configure anything extra. I just created two separate calls and it was able to do that. Now, of course, what if we want to not preserve the context for whatever reason, or just to see, you know, what will happen if it gives hello world example of Java still. So I'm going to stop my application here. In fact, I guess I didn't have to. I could have just done hot reload. But we're going to now enable this no chat memory provider supplier. Okay, so let's try it out again and do the exact same thing, but now without preserving the memory. So again, we're going to ask it, what is Java? And then can you give me a hello world example for it? So you can see here, we're interacting with the model, waiting for the response. So we ask, what is Java? It again answers with what is Java? And then the second question, can you give me a hello world example for it? And as you can see, the request is much shorter, right? Because there's no previous context that's being passed to the model. And as a response, we ask, it'll respond. And sure enough, it responds with a hello world in Python, just as we expected. So these models are all a little bit biased to Python, except actually, it does seem like it's responding with different languages. So it answered first with Python, then JavaScript, and actually with Java as well. So I was a little bit wrong, but it didn't know in any case that we asked it about Java. And so it's just kind of guessing, right? It's guessing. And in this case, it's trying to be as agnostic as possible and returns all these different hello world examples in different programming languages. Another capability that you have with Quarkus and LangChain for J is that you can have multiple conversations at the same time and keep them separate. So you do that with this memory ID that I show here as an example. So here we have another method called parallel chat, and we have a memory ID annotated parameter with an integer ID, and then a user message for the actual message that we're sending to the LLM. So the implementation of that is again in the same entry command class, and we can see here there's another class here that is called parallel, and we want to try to maintain a parallel conversation. So again, we have a run implementation for our CLI command. And in this case, we have a few questions, or a few, kind of interactions with the LLM. So the first one we call the parallel chat with ID 1. And that's important to keep in mind, right? This 1 refers to the memory ID that we have configured here in the register AI service interface. And so our first message here is, you are a smart enterprise developer that chooses a robust programming language with a vast ecosystem. Use a framework that is Kubernetes native, has blazing fast startup time, and supports native compilation out of the box, and supports LangChain4j. Now, that's a pretty lengthy kind of context that I'm giving to the LLM, because the more you're specific, the more information you provide, the better the LLM is going to respond, right? So I'm trying to be, kind of a little bit verbose and give it as much context as possible, so that I can get hopefully a response that I'm hoping for. So then I have a second interaction with the LLM with ID 2, and I say, you are a Python developer. Again, remember, here we said memory ID 1, here we're setting memory ID 2, meaning that we're going to have two separate conversations going on. So one conversation where we're saying, you're a smart enterprise developer and blah, 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 hoping that, of course, it will respond with some Java code. And then the second one, parallel chat 2, you are a Python developer. Now, the third question, so we're keeping the memory going here. Again, with memory ID 1, though, we're asking it, write some code in the best programming language based on our previous conversation. Now, because we're using memory ID 1, it should refer not to, you are a Python developer, but it should refer to the context of this interaction here with memory ID 1. So we have two separate conversations. I could even send a third parallel chat request with number 2, and then ask it to do the same thing, and then probably it would respond with Python. But in this case, my bet is on that it will respond with Java, and my bet is on Quarkus, even though we didn't say you are a Quarkus developer, but we gave it some context. Kubernetes native developer, very fast startup time, supports native compilation out of the box, and supports LangChain4j. So we'll see if it responds with some Quarkus code. So let's try it out. So I'm gonna again start our application, Quarkus dev, and in this case, our parameter here is parallel, right? The command name here is parallel. So let's try that out and see what happens. So we're starting up our Quarkus project with live reload. So if I want to make changes, it'll do those on the fly. Anyway, so here's our first interaction. You are smart enterprise developer. Let's see what it answers. I recommend using GraalVM with Quarkus. Well, that's great. That's what I was hoping for based on the information that I provided. So the LLM is smart enough to figure out that if you want to use an enterprise language that supports LangChain4j, it's very fast to start up, then of course you should use Quarkus. Sorry, Spring developers. The LLM responded this. And then we see the second request that we're making, which is, you are a Python developer. And it says, oh yes, I can help you with Python programming and blah, blah, blah. Then our third request with chat ID 1 means that the context that we're passing on to the LLM is the previous conversation of our first conversation, right? So you are a smart enterprise developer, and then the assistant responded with, yeah, sure, Quarkus sounds like a great fit for you. And then we ask it, write some code in the best programming language based on our previous conversation. And because of our memory here, it remembers that that should probably be Quarkus. And let's see what it does. Yes, let's create a simple example using Java with the Quarkus framework and integrating LangChain4j. And it sets up a Quarkus project and adds dependencies for LangChain4j, and then creates a post method and whatever more. It looks like it creates some Quarkus code to interact, to do some interaction, and then runs Quarkus dev and even adds some tests and everything. So, hey, it looks like everything worked I hope this kind of makes sense to you in terms of what you can do with memory when you're interacting with LLMs. So just to recap, right? We were interacting with LLMs with multiple messages and able to keep that conversation in the context of the previous conversation going. In the second example, you saw that we had parallel conversations and it was able to keep those separate, right? So in the first question we asked, you are a smart developer. The second one, you're a Python developer, keeping those two separate. And then we referred back to the first conversation. And you could see in the logs that with Quarkus and LangChain4j, it passes in the right bit of context from that initial conversation. So hopefully this will help you a little bit on your path to becoming a good AI developer with Java. If you want to find out more about how to configure the context with memory, go to the docs.quarkiverse.io/Quarkus-LangChain4j, and then you'll find more information about chat memory. And you can even figure out if you want to create a custom chat memory provider, how to do that as well, and then create custom chat memory stores as well. Stick around for the next episode. Of course, like always, like and subscribe if you like this. I would really appreciate it. And then in the next episode, we're going to dive further into all these different topics for interacting with AI, because we're not done by any stretch of the imagination. There's a lot more cool stuff that we can do. So see you next time. Thank you for joining.